Hello Chem 2NP students, this is Dr. Baxley. In this video, we are going to learn about the SI system of measurements. So first, let's talk about measurements. What is a measurement? A measurement is the assignment of a numerical value to an object's physical property. For example, you might measure the length, or the mass, or the volume. We may want to measure the length of this red stick, or the mass of some purple pebbles, or the volume of some green liquid. Units are also important whenever we're measuring something. Units must be assigned to the numerical quantity to convey the relative size, or magnitude, of the property. For example, if I were to measure this shoe and I said that it was 7.3, you might say, 7.3 what? Exactly how long is the shoe? But if I said that the shoe was 7.3 inches, then you would understand exactly how long the shoe was. What is a system of measure? A system of measure are standard amounts of various physical properties. For example, an inch, a pound, or a gallon. In chemistry, we use the SI system, which stands for Système International. It is the international system of measurement. This is used by scientists and most of the rest of the world. You have probably heard of it called the metric system. In the metric system, there are base units and prefix multipliers. The common base units that we are going to use in chemistry are going to be the kilogram for mass, the meter for length, and the second for time. You can pause the video and copy this table down into your notes. Along with the base units, there are prefix multipliers that can make the value larger or smaller. In this table, I'm showing you the name of the prefix, its symbol, the decimal equivalent, and the exponential value. The only two things that you really need to know for this class are the symbol and the exponential value. You may wish to pause the video and write down these 6 symbols and their corresponding exponential values. There are other prefix multipliers aside from the 6 that I have shown you here. For example, there's also one called the pico. However, for this class, the only ones that I'm going to hold you responsible for are the 6 that are on this table. It is a good idea to make flashcards to start learning these prefix multipliers if you do not know them already. The 2 that I find students get most confused about are the bottom 2. Notice the second one from the bottom, the micro, has a funny symbol that is a micro symbol. It looks like a U with a little flag on the bottom. It is important that you are able to write this symbol correctly and that you know what it means. I find that students often get mixed up between the micro and the nano, probably because these are the units that are least used in your everyday life. One way that I remember which one is which is that the nano begins with an N and the exponential value on nano is 10 to the minus 9. Notice that nano and 9 both begin with the letter N. Another thing that is useful to note is that most of the exponential values have exponents that are multiples of 3. So kilo is 10 to the 3, milli is 10 to the minus 3, micro is 10 to the minus 6, and nano is 10 to the minus 9. Noticing that most of the exponential values are multiples of 3 might help you memorize these prefix multipliers faster. Now that we know what the prefix multipliers are, how do we use them? Let's do an example with kilogram. We know from the previous slide that kilo means 10 to the 3. Therefore, 1 kilogram is equal to 10 to the 3 grams. Notice that one of them has the K for kilo in front of it, and the other one has the exponential value in front of it. This equivalency is called a conversion factor because it can be used to convert from one unit to another. We will learn more about how to do conversions in the next video. Now that you know how to use prefix multipliers, it's your turn to give it a try. Pause the video and fill in the blanks to create conversion factors for the following. Okay, are you all done? For the first one, you should have said that 1 centimeter is equal to 10 to the minus 2 meters. For the second one, you should have said that 10 to the minus 9 seconds is equal to 1 nanosecond. And for the third one, you should have said that 1 microgram is equal to 10 to the minus 6 grams. Now you may be used to seeing that 100 centimeters is equal to 1 meter. Mathematically, that's the same thing as saying 1 centimeter equals 10 to the minus 2 meters. So it is okay to give this as your conversion factor instead of 1 centimeter equals 10 to the minus 2 meters. Either one is okay. All of the units that we have used so far are standard units. There's another type of unit called a derived unit. What is a derived unit? It is a unit that is obtained by multiplication or division of the base units. Let's do an example. Let's say that we wanted to take the volume of a cube, and the cube was 1 centimeter tall, 1 centimeter wide, and 1 centimeter deep. Now we make a cube out of it. The volume of this cube is equal to 1 centimeter by 1 centimeter by 1 centimeter. This is the same as 1 centimeter cubed. In chemistry, we have defined 1 centimeter cubed as being equal to 1 milliliter. So you can write 1 milliliter equals 1 centimeter cubed, or vice versa. This is a conversion that you must know, so add this to your list of flashcards. Always know that 1 centimeter cubed is equal to 1 milliliter. Now, do some more practice. Fill in these blanks to create conversion factors for these quantities. Are you all done? Okay. The first one, you should have gotten 10 to the minus 9 grams is equal to 1 nanogram. In the second one, you should get 10 to the minus 6 liters is equal to 1 microliter. For the next one, 1 millisecond is equal to 10 to the minus 3 seconds. For the third one, 1 deciliter is equal to 10 to the minus 1 liter. For the next one, 10 to the 3 meters equals 1 kilometer. And 1 centigram equals 10 to the minus 2 grams. It is important that you are able to write these conversion factors quickly and correctly at all times. So, if you aren't comfortable with them yet, make sure to make some flashcards and start to get to know them. These conversion factors will help you to be able to convert from one metric unit to another. However, what if you wanted to convert between systems? For example, what if you knew the measurement in feet and you wanted to convert it to centimeters? In that case, you will need to use different conversion factors. This table here shows several conversion factors that will help you convert between systems. You do not need to memorize this table. There's only one value in this table that you need to know, and that is that 1 inch equals 2.54 centimeters. So make sure you add this to your flashcards and memorize it. Notice that this says that it is an exact conversion. That means that these numbers have infinite number of significant figures. So this conversion will not limit your significant figures when you're doing conversions. For the rest of these conversion factors, don't worry about memorizing them. If you ever need one of these conversion factors on a test or a quiz or your homework, you can always look them up in this table. So that's the SI system. On the next page in Canvas, you are going to do some textbook reading about the SI system to learn about it in more depth. After doing that reading and before continuing to the following page, make your flashcards and start to memorize the following. Make sure that you know how to create conversion factors using the prefixes kilo, deci, centi, milli, micro, and nano. Know the conversion factor between milliliters and centimeters cubed, and know the conversion factor between inches and centimeters. That's all for this video. We'll see you next time.